Now I'm going to be talking to you about the addition rule of probability. If you have a look on the board, guys, that's pretty much the rule. Now you can see what I have on the left-hand side of our equation. We've got the probability of A or B. Now you can see this bigger little symbol here that looks like a U. That's our symbol for, or the notation for, or. It's asking for the probability of the event A or event B. Now to get that, what we do is we add the probability of event A to the probability of event B. We add those together, and then at the end we subtract away the probability of A and B. Now you can see the upside down looking U is the notation for AND. So please remember these. That one's the OR, that one's the AND. Don't get confused with those. And that's what we're going to be subtracting. And you can see that that is the common part of A and B. So the overlapping part, which we can also call the intersection. That's what we subtract away at the end. And that result will give us the probability of A or B. So try to remember this formula, write it down on the side of your paper, and then we'll use that throughout the lesson. So let's go to question 1. They give us the probability of event A, and they give us the probability of event B, and they give us the probability of A and B. And they're asking us to find the probability of A or B. Remember, the U is the OR. I'm simply going to use the rule that we introduced to you earlier. So that's all I'm going to use. I'm going to put the values in. So you can see that the probability of A or B is going to be probability of A, and they give it to us here. And they give us a probability of B. We're going to add those together and subtract away the common part, the intersecting parts, which is 0.2. If you simplify that, add and then subtract, you'd get 0.7. So that is the probability of A or B. Let's try another one, question 2. They give us the probability of A, they give us the probability of B. This time, instead of the probability of event A and B, they give us probability of event A or B. So it's 0.8. And what we want this time is the probability of A and B. But again, guys, we're just going to put it straight into our formula as usual, this one here. And you can see that what we want is this one. Can you see that that's what we want? That's what they're asking us to find. If I rearrange the equation or the formula by swapping these two around, this negative P probability of A and B will be positive on the left-hand side. And then if I subtract that away, it looks like that. So basically, I'm just swapping them around, okay? Just rearranging the formula. Probability of A, they give it to us here. Probability of B, they give it to us here, 0.4. The probability of A or B is 0.8. So just put it into our formula. Just calculate that for me. Should be simple, 0.1. That is the answer. Question 3, probability of A. This time it looks a bit different. They don't give us the value of probability A. They also don't give us the value of probability B, but they tell us the relationship of probability of A and probability B. Probability of A is 4 times the probability of B. That's some information that gives us, so that's a bit of a unique information, isn't it? So I'll show you how we're going to use that later. They also give us the probability of A or B, probability of A and B. So they give us those parts. And what they're asking us to find is probability of event A alone. You can see they tell us the probability of A is 4 times the probability of B. So I'm thinking we might replace this with 4 times probability of B. So then everything will be in the terms of probability B. That will be probability B. And this one we can also write in terms of probability of B. And these values, they give it to us. They give us the exact values. So I'm pretty much going to replace it. Probability of A or B is 0.8. Probability of A and B is 0.2. And you can see I've replaced the probability of A, as I said, with 4 probability of B. Probability of B, just leave it as it is. We can now gather the like terms. That will become 5 probability of B. And you can see the constants. I just moved it onto the left-hand side so we can gather it together. 0.8 plus 0.2 is simply 1. To calculate probability of B, what we have to do with 5 is divide it. So 1 divided by 5, which is 1 over 5, is also written as 0.2 as a decimal. So that's probability of B. What we really want is the probability of A, isn't it? But they tell you in the very beginning of the question that probability of A is 4 times the probability of B. So simply, guys, because we've got the probability of B, multiply it by 4, and then you'll get a value. That would be the probability of A. Question 4. Of the 100 students, 50 study chemistry, while there are 30 physics students. 50 do chemistry, 30 do physics. And they also give us additional information. If there are 40 students who don't like either chemistry or physics, find the probability of, firstly, that studies chemistry. You can see that there's clearly 50 who study chemistry. And they tell us that there are 100 students. So the probability of people who study chemistry will simply be 50 out of 100. 50 out of 100, which is 50%, which is half. I'll just keep it as a decimal, 0.5. We want to find the probability of those people who study physics. 30 people study physics. Again, you can simplify. It will be 3 over 10, or as a decimal, 0.3. Okay, now we want to know the probability of the people who studies neither chemistry or physics. So neither means they don't do chemistry or they don't do physics, or they don't do both. That there are 40 students who don't take either chemistry or physics. So that's the people. So 40 out of the total 100. And you can simplify that, and that will be 0.4. D, studies chemistry or physics, which means they could study chemistry, or they could study physics, or they could do both. We want to know the probability. It's simply 1 minus 0.4. Where did I get the 0.4? From our part C. 0.4 is the probability of students who don't do any of the physics or chemistry. So if I subtract that away from the total probability of 1, see how 1 is our 100%? If I subtract that away from 1, the remaining would be the people who do chemistry, who just do physics, or the people who do both. We're just eliminating the people who don't do any of them. And that just becomes 0.6. Now we'll do another one. It says study chemistry and physics. Remember our formula here? I'm simply going to use that. Upside down U. Remember this one here? That's the probability of chemistry and physics. We've got the values here. Probability of chemistry or physics, we've just calculated it, 0.6, isn't it? The probability of C, we've calculated at the very beginning that it's 0.5. Probability of physics calculated in part B, 0.3. And then this is the only unknown value. What we'll do is we'll move this onto our left-hand side so it becomes positive, and all the constants, I'll just gather it up on the right-hand side, and all I have to do now is gather it up, simplify, and then we'll get a value or something that looks like this. So that's the final probability. So see how this one always comes handy? So make sure you remember this one, the main formula, off by heart.